Okay, I know I've thrown a lot at you, so let's jump back into the slides for a quick review. Never use .wait or .result. If we can, we should always be using the await keyword. Especially nowadays, we're in .NET 9, we're in C# 13, and async await came out in C# 5. So many, many years ago, async await was introduced. When it was first introduced, sometimes we couldn't use the await keyword. Sometimes there was a method in a library that somebody else wrote that was not using async await. It wasn't returning a task. And we had to use .wait or .result. Nowadays, that's much less common. And pretty much the only time nowadays where we can't use the await keyword is when implementing interfaces. I still see some interfaces that say have a method that return a bool, and not a task bool, just a bool. And if I have to use async await, or if I have to call a task that uses async await, then yes, we have to use sync over async. But in that case, the recommendation I want to give you is to use getAwait or getResult. Now, getAwait or getResult does the same exact thing as .wait, and it does the same exact thing as .result. It replaces both of them. Now, it is still dangerous because just like .wait and just like .result, it's still a blocking call, meaning if thread 1 comes across getAwait or getResult, just like if thread 1 came across .wait, just like if thread 1 came across .result, getAwait or getResult says, thread 1, you stay right here. You're locked with me until this background task finishes. And then once that background task finishes, everything gets freed up. So getAwait or getResult is still a blocking call. It's still going to block the calling thread. But if you find yourself in one of those rare situations where you can't use async await because, say, you're implementing an interface that doesn't allow you to return a task, then getAwait or getResult is better, because if you've ever used .wait or if you ever used .result and an exception happens in your task, the task throws what's called a system.aggregate exception. An aggregate exception is essentially an exception that holds multiple exceptions. And an aggregate exception is totally valid because multiple exceptions might occur inside of a task and it wants to feed all of them back to you. But if you've never worked with an aggregate exception before, and you've never seen those call stacks or those stack traces before, it's a little confusing to work with because you have to dig a layer deeper to find your code. So with getAwait or getResult, this actually returns the exception that happened in your code. So if a timeout exception was thrown, getAwait or getResult will throw a timeout exception with the stack trace that you expect, whereas .wait and .result will throw an aggregate exception, and inside of that will be your timeout exception. So again, always use await. This should be the default for all of our code. But in those rare situations nowadays where we have to do synchronous code, then getAwait or getResult is our best option. Fire and forget tasks. If you ever have a task and you don't care when it finishes running, meaning you don't really care about awaiting it before moving on to the next line of code, check out my NuGet package, Async Await Best Practices. You can use the .safe fire and forget extension method. And again, that signals to any other developers reading your code that we're not waiting for this task to finish before moving on. And it's got all the proper guardrails in place to ensure that that exception does get rethrown. And it also allows you to handle that exception gracefully. Avoid return await. So in those examples where we are only using the await keyword in the return statement, we can just remove the async keyword, remove the await keyword, and return the task. That helps ensure that we don't have multiple thread switches when we only need one. But there's a big caveat in here, and we showed it a bit in our sample app, where if we're inside of a try-catch block, so if we're saying return await inside of a try-catch block, keep that await there, because if you just return the task, well, then that tells .NET, hey, we're returning from this method, exiting the try-catch block, meaning that catch is never going to catch the exception that you wanted it to. Or also, if you have a using, so a disposable object is in your method, you say, you take advantage of the using keyword to dispose of it once the method's done. Again, in a situation like that, we still want to keep return await, because if we return the task, just like with the try catch, if we return a task from a using block, well, then the object is going to be disposed. And if we needed that object, you're going to see weird object dispose exceptions in your code. So avoid return await where you can. If the only place in your code or the only place in your method where you're using the await keyword is in the return statement, just return the task instead, unless you're inside of a try catch block or you're inside of a disposable using block. Utilize configure await false. So if you have to return to the calling thread, then don't. But for me, as a mobile app developer, a longtime Xamarin .NET MAUI developer, my rule of thumb is if I'm not in the UI layer, so we use the MVVM architecture in .NET MAUI, that's what we were using in our sample app, and the view in MVVM is the only place where I interact with the UI. So in my view model, there's no UI code. In my services layer, there's no UI code. In my models layer, there's no UI code. In my database layer, there's no UI code. And so my rule of thumb is if I'm in my UI layer, I don't use configure await false. But if I'm in my view model layer, my services layer, my database layer, anything else where I know I don't need to return to the calling thread, then I use configure await false everywhere. The note here, and we're going to dive deeper into what a synchronization context is in the next section, but if your UI does not use a synchronization context, like ASP.NET Core does not have a synchronization context, then configure await false in ASP.NET Core is the same thing as configure await true, because really what's going on under the hood when we say configure await false, we set the synchronization context of that task to null. We essentially get rid of it. And the synchronization context, which again, we're going to dive deeper into this in the next course, the synchronization context is responsible for returning back to the UI thread or the calling thread. So by setting configure await false, we essentially null the synchronization context so that when .NET comes back in and says, oh, what thread did you want to return to? Or what calling thread called you so that I can go get it for you? When it sees synchronization context is null, then it doesn't matter. So if you're doing WPF, WinForm, Xamarin, .NET MAUI, WinUI, Blazor, anything that has a synchronization context, this is all valid, but we'll dive deeper into our next section about why ASP.NET Core is a bit of a special case. And likewise, with configure await, we can also use configure await options. So there's continue on captured context, which attempts to return to the calling thread. So again, continue on captured context is the same thing as configure await true. And because configure await true is the default, it's the same as just saying nothing. Configure await options.force yielding forces an await on an already completed task. So even if that task is already finished running and it's completed, and the await keyword normally wouldn't switch threads as a performance optimization for us, we can always call force yielding on our configure await options to say, hey, even if the task is done, do a quick thread switch. And again, I like to do this in my apps where I need to update the UI. So even if that task is finished, I want to first free up the UI thread, free up the calling thread by using force yielding so that the UI can update via the UI thread and then return and grab the results as needed. So it essentially behaves as if the task wasn't already completed. Configure await options.suppress throwing. This one scares me. I don't use it a lot, but there are some valid use cases where you don't really mind if an exception is thrown. And you can say configure await options.suppress throwing. And even though you're using the await keyword, like a good C# async await developer, that exception won't get rethrown, even if it did happen inside of the task. And finally, we have configure await options.none, which is the same as configure await false, where we will not return to the calling thread. And because these are enums that are flags, they can all be chained together. Utilize value task. So when a method's hop path doesn't use the await keyword, instead of returning a task, which has to be initialized on the heap and has a lot of overhead, we can use a value task, which lives in the stack, and we get a little bit of performance improvement there. Async enumerable. So like we saw, if we are streaming data, if we're ever making an API call that returns many results, and we want to show that to the user as the results roll in, iAsync enumerable is your best friend. It allows us to update the UI as that data comes in. It gives us a better user experience. Just remember, we still want to pass in a cancellation token for our iAsync enumerable method, but we want to take advantage of the enumerator cancellation attribute because, again, that tells .NET to pass this token, the parameter for our method, into the .NET runtime iterator, saving us the trouble of having to double check to see if that token has been canceled, because .NET will now do that for us every time our await for each loop iterates. Wait async. So again, anytime we write a async task method or async value task method, anything that's going to be long running in the background, we always want to have a cancellation token parameter. And we know that as good C# developers, and we would never write code that doesn't allow a cancellation token to be passed into our async task method. But there's still code out there that exists that doesn't allow us or doesn't take a cancellation token as a parameter. And for that, that's okay. We'll just say .wait async, and we can essentially use that to bolt on a cancellation token to a async task method that we're calling that doesn't allow it as a parameter. Okay, and finally, iAsync disposable. I didn't have an example of this in the sample code, but let's talk through it right here. iDisposable has been around in .NET for a very, very long time. iDisposable is an interface that will add to any class that uses unmanaged resources that maybe the garbage collector can't detect, and we want to free up those resources when we're done. So with iAsync disposable, it also allows us to dispose of an object when we're done using it. But now it allows us to use the await keyword in that dispose method. So FileStream is a great example because when we use, when we're reading data from a file, well, that's using file IO. It's using a lot of buffers and streams to store that information in memory. And tearing all of that down is expensive. So if we can use iAsync disposable instead, then that allows us as developers to use the await keyword and, again, free up the calling thread from having to do all that disposal on, say, the main thread. The way it works, super similar to iDisposable. And iDisposable, we would have a using block just like this, but with iAsync disposable, we just append the await keyword and we add in configure await false if we don't want to return to the calling thread here at the end, just like this. And this looks a little funny because all the code inside of this await using block is going to execute first. And then when we exit this block, so essentially at this closed curly bracket, this is when the await keyword hits. So the way it reads, it almost reads like we're going to call the await keyword and do some stuff on the background thread here. But in reality, that await applies to the using, which gets executed here at the end. So keep that in mind. And again, yes, you can absolutely use configure await false or configure await options with your iAsync disposable, and you should, unless you need to return to the calling thread. But remember, we're going to execute this using block first, then we hit the await keyword. That was a lot to take in. And I wanted to share with you one more time a link to my website where you can find even more resources on async await best practices. So this is where you can find the NuGet package, async await best practices. It's also all open source. You can find that code on GitHub as well. I've posted a ton of helpful articles here on this website where you can find even more information on task and synchronization context and execution context. Some of the information we're going to dive into in the next section is all posted there for you. There's tons of information out there on this topic, and it does go very deep. So if you get through this course and you want to continue learning on about async await, check out codetraveler.io/async await best practices. And I'll see you in the next course where we dive into some of these internals ourselves.